Mr. Ben on here with week 7, day 3, math distance learning, and we are going to be on page 973 to do the last lesson in the book. So chapter 12, lesson 12, it says that you're making a model, and on most of the problems that is going to be true, but ultimately all of the problem solving investigation lessons are basically, hey, can you solve word problems? So solve word problems, show your work. And it's trying to give you word problems that are going to be best solved, most efficiently solved by making a model. So you're going to want to draw a picture. Making a model just is a fancy way of saying draw a picture. So we're drawing pictures today to solve math problems. Okay, that's it. We're going to go through the first two together. And at the end of the video, I am going to give you hints on most of the other problems because I know that in the past, historically on this, there's some problems that kids can't figure out how to get started on. And so I'm going to give you a hint to try to make it so that you are not stuck. Okay. All right. So here we go. Nick is helping his sister put away her alphabet blocks. Oh, what a good brother. To fill one layer, it takes 9 blocks. If there are 6 layers, how many blocks would be in a box? How many blocks would be in a box? Something to say. So yeah, some of us right now are like, I already know the answer. I know what to multiply. I did it in my head. I'm done. But we're practicing drawing. So it's sometimes math is about get an answer, and sometimes math is about show how to get an answer. And that show how to get an answer part is way more important than the answer itself. You don't need to it's not very often that you need to just quickly generate an answer when you're, actually interacting with humans outside of math class. But you always need to be able to clearly explain yourself. If you can't clearly explain your thinking, whether it's math, whether it's reading, whether it's, as an adult, whether, politics, whether it's the things that you believe in, if you can't explain yourself and listen to other people's explanations, it's bad news. Okay, so we're practicing how to show our work, how to explain why we know an answer to be true. And they've drawn it for us on this one because, I don't know, they thought you really needed your handheld. But the bottom line is we've got a base layer of 9 blocks, which we could draw like so and say, look, it's 9 blocks on the bottom. According to the problem, there's going to be 6 total layers. So this is layer number 1. And it's going to keep going up for an additional 6 layers. So layer 2, 3, 4, 5, and 6. So eventually, it's going to be all the way up here. This invisible area up here will be filled in. So every layer is 9. So this is 9, and then it's going to also be 9, and it's going to also be 9, and it's also 9, and it's also 9, and it's also 9. How many groups of 9 is it? That's 1, 2, 3, 4, 5, 6 groups of 9. 6 groups of 9. Groups of is just a fancy way of saying time. So this is 6 groups of 9. So that's a total of 54 blocks in that little tower thingy. So they put away. Good for them putting away their toys. So the answer is 54. This is my drawing of why. Again, today we are not just finding answers. We are showing our work with pictures and models. So you get to draw today. That's good. I hope that you're not a math student who goes, I don't like to show my work. Because that's, sometimes that happens. And there's no need for it. The whole point of math is to be able to explain yourself well. So please don't ever be that math student who's like, I want to do it faster. I just want to get it done. No. Okay. Evelyn, on the next page, we turn the page in case you didn't see that. Evelyn wants to mail a package to her cousin. What's the volume of the package if it is 6 inches long, 4 inches wide, and 4 inches tall? So we're asked a volume question and they give us the dimensions. So yes, ultimately, it's just multiplication. And yes, they already drew it for you, but on these ones, guys, they didn't draw it for you. I don't know why they make it. So anyway, practice drawing this on your own. If you were going to sketch something that was a 6 by 4 by 4, it doesn't have to be exactly to scale. You just need to know that she's mailing a package and it's going to be 6 inches long, which, by the way, I would draw it differently. If they say it's 6 inches long, I'm going 6 inches long, and then I'm going 4 inches wide, and then I'm going 4 inches tall if I made that line that long. Trying to make it approximately, equal. So we'd have something like this very boxy loaf of bread looking thing right here. So that's my picture. And now I just need to solve volume 6 times. I'm going to do 4 times. Well, no, I'm not. The reason I'm not doing 4 times 4 in my head first is because I know how to multiply by 4 in my head really well. So I'm going to do 6 times 4 is 24 first. And now I can use, for 24 times 4, the mental mathematical strategy of double. So 24 doubled is 48, and 48 doubled will be 96. How did I double 48 quickly in my head? I actually doubled 50 in my head and subtracted 4 because there were 2 groups of 2 that I'd left out. But you can stack it if you want to. It's fine, doesn't matter. You get 96. So the final answer is 96 cubic inches. Okay, so that's it. You're drawing pictures. I am going to quickly go through the problems here for the apply the strategy section to give you some hints to make. I'm going to read every question and I'm going to tell you how to get started on it. I'm not going to draw the pictures for you. That's the whole challenge, is figuring out how to draw the pictures, but I don't want you to get super stuck. So it says solve each problem by making a model. So you need to draw. On an assembly line that is 150 feet long, there's a workstation every 15 feet. The first station is at the beginning of the line. How many workstations are there? Draw a picture of this situation. Draw a picture of an assembly line, like a line, like a treadmill looking thing, and put workstations every 15 feet to get a sense for what this is going to look like. And I would do it until you've done all 150 feet. So basically repeated addition. So draw a picture of what that looks like. Okay. If you need more space than this, get out a sheet of paper and do that. Number 2 says a store is stacking cans of food into a rectangular prism display. The bottom layer has 8 cans by 5 cans. There are 5 layers. How many cans are in the display? This is the same as the first problem. This is like the example problem that we did, okay? We're looking at base layers. We're going to draw that base layer, and then we're going to draw what it might look like if it was filled in and solve. Number 3, the distance around the center ring at the circus is 80 feet. So the distance around this is 80 feet. A clown stands every 10 feet along the circle. How many clowns will there be? For this problem, this is usually one of the problems that causes some problems. Any circle could be cut and then made into a line. Okay, so but you got to think about, well, you could do it that way. I would not use their picture here. You could if you wanted, but you need to think about if you're distributing clowns every 10 feet around a circle, how many clowns are there going to be once you get to 80 feet? Remember that a clown will not be standing in the exact same place as another clown at any point. They're all 10 feet apart. Good social distancing clowns. Number 4, Martino wants to arrange 18 square tiles into a rectangular shape with the least perimeter possible. Cool problem. Perimeter is the distance around a figure. How many tiles will be in each row? So you need to experiment here a little bit with how can you make a rectangle that has exactly 18 squares in it, where the surface area or the area of the rectangle is 18. In other words, I mean, if you literally, again, if you've got little squares or little blocks or something like that, this would be a good problem to bust them out on. Get 18 of them out and start arranging them into rectangles. And you'll start to notice the different ways that you can make rectangles. Well, the area and perimeter are not equal. They're not the same thing. And you can have, as this problem is trying to get you to see, you can have something that is, well, let's do one example really quick. One really quick example. Let's imagine this problem was about having an area of 10. So if I'm going to make 10 squares, I'm going to make it way less than that. I'm just going to make it 4 squares. I could take 4 squares and arrange them like this. This is an area of 4, right? This is a 2 by 2. Okay. Or I could take those squares and I could make them like this instead if I so chose, and this would be a 4 by 1. Okay. Both of these have an area of 4 square units, but the perimeters are not the same. This one's perimeter is 1, 2, 3, 4, 5, 6, 7, 8. So this is 8 around. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 10. So the perimeter around this is greater than the perimeter around this, even though they have the same area. So I'm not going to solve, problem 4 for you, but think about arranging squares like that into 18 squares into different shapes that will give you rectangles. And then which one would give you, remember he wants the least perimeter. How many tiles would be in each row? Okay, you turn the page, it's more of the same. I'm going to read the problems to you, walk you through how to start them. 5 friends are standing in a circle and playing a game where they toss a ball of yarn to one another. If each person is connected by the yarn to each other person only once, how many lines of yarn will connect the group? This is a retelling of a classic problem called the handshake problem. The handshake problem is people stand in a circle and everybody shakes everybody else's hand one time. How many handshakes occur? So this is the idea is there's a ball of yarn, you're holding onto a string and tossing the yarn to someone else, and you never are going to have the same person. How is it again? If each person is connected by the yarn to each other person only once. So if I throw the ball to you with the yarn, you can't throw it back to me because we're already now connected. It's the handshake problem. You're going to want to put those 5 friends in a picture standing in a circle, and you're going to want to literally draw the yarn as the line that would connect them as they go. Okay. You can't retrace over, exactly any of the same lines. So it's the handshake problem. You can think of it as handshakes. Yarn is a cool way to think about it too. But that's what they're doing. Number 6, look for a pattern. In the figure below, there are 22 marbles in box A. To go from box A to box B, exactly 4 marbles must pass through the triangular machine at a time. Exactly 5 marbles must pass through the square machine at a time. Describe how to move all the marbles from box A to box B in the fewest moves possible. This is not drawing on this one, really. This is more of a trial and error problem. This is a cool problem too. So again, they didn't write that there are 22 marbles here, but I would write 22 so I don't forget 22 right there. And then you need to start thinking about how can you get all of them through. For example, if you tried to only use the 5 at a time tube that goes through the square, you're going to pass 5 marbles through, and then you'll have 17, and then you'll pass 5 through, and then you'll have 12, and then you'll pass 5 through, and then you'll have 8, and then you'll pass 5 through, and wait, I said that wrong. If you pass them through, you'll go from 22 to 18, and then 14, and then 10, and then 6, and then 2. And then there'll be 2 marbles left over here, and you can't get 2 marbles, that you'll have failed because you can only send 5 marbles at a time through here and 4 marbles at a time through there. You can't, there's no way to get 2 marbles to box B. So you have to send exactly 5. It's not like a maximum. It's exactly 5 and exactly 4 at a time. So do some trial and error. How many marbles are you going to send through? Once you figure it out, write a description of how many marbles, how many times you send marbles through each passageway. Okay. All right. Number 7, the volume of a rectangular prism. By the way, in case this wasn't obvious, if you want to, after I read a problem, pause the video, solve the problem, and then unpause the video. Okay. The volume of a rectangular prism is 5,376 cubic inches. The prism is 14 inches long and 16 inches tall, wide. How tall is the prism? This is an algebra problem where you have what we traditionally think of as the answer, and you're looking for a missing piece of the puzzle. It's an advanced version of saying, hey, the answer is 12, and it's 6 times what is 12? And you have to find that missing variable. 6 times what is 12? 6 times 2 is 12. So 2 would be the answer. This is doing that. It's saying, hey, here's the volume. The volume's over here. We have our answer. And we know we need to multiply 3 numbers together to get there. I'm giving you 2 of the numbers. What's the other number to get there? Okay, so it's a little algebra problem. You don't have to draw for that one, I don't think. if you show your work thoroughly. You could sketch a picture of what's happening maybe, but it's not a lot of drawing. All right, last one. The table at the right shows the number of minutes Danielle spent practicing the trumpet over the last 7 days. If she continues this pattern of practicing, in how many days will she have practiced 340 minutes? So I see that she practices for 2020, then 35, then 2020, then 35, then it says 20. I'm assuming that that it's not a weekly. Here's what I don't know. I don't know if they mean, they don't tell us. Let's read the problem again. So it's maybe a confusing problem. I don't know what the right answer is going to be, because what they don't tell me is if the pattern is this is what she does every week, and she's going to keep repeating that problem, that same every week. She's going to keep doing 20, 20, 35, 20, 20, 35, 20, then restart, 20, 20, 35, 20, 20, 35, 20, then restart. That might be the pattern. I think that's not what they want, though. I think what they want is probably that the pattern always goes 20, 20, 35, 20, 20, 35, 20, 20, 35, 20, 20, 35, and so on. There's no way of knowing because they don't tell us. So pick one of the patterns that you'd rather do, and then figure out how long it will take her to practice a total of 340 minutes, how many days it would take to do that, because it doesn't say how many weeks, it says how many days will it take her to reach that total. There's a lot of ways to solve that problem. Some are faster than others, it doesn't matter, but show your work when you solve it. Okay, that's the assignment, and tomorrow we'll do the review, and congratulations, you're just about done with, you are done after this, after you finish your work today with all of the lessons in math.